Hi class, my name is Giancarlo Royano. This is my ID. In this exercise, I calculate the magnetic flux and the induced electromotive force in a simple routine coil system. First, I determine the initial magnetic flux for one loop using the dot product between the magnetic vector and the area vector. The area vector is directed along the axis, therefore this is the magnetic field vector is this is to calculate the magnetic flux. The dot product is this since only the components in the same direction contribute, only components are multiplied. The result for one loop this is result. Then, because the system has 18 turns, I multiply the flux by the number of loops. This is the total magnetic flux obtained was this result. Next, the coil begins to rotate with an angular velocity defined by W to Pf using a frequency of 70 Hz is equal to the result, because the coil rotates the angle changes with time according to cos Wt. So the instantaneous magnetic flux becomes as I replace the values, the equation is this point. Then I evaluate the flux at different time. For t equals 0 seconds, this is this results. For t equals 10 seconds and t equals 60 seconds, the cosine there is equal to 1 because the angle corresponds to an even multiple of p. Therefore, the magnetic flux at both times is also this result. To find the exact time when the instantaneous flux equal to initial flux and equal book expression. This happens when cos Wt is equal 1. Solving for time gives t equal n for 70, where n is an integer. The fundamental period of rotation is these results. Finally, I calculate the induced electromotive for using Faraday lens law. The equation is this is equation. After differentiating the flux equation, the induced EMF becomes this equation, replace of value, this is of result. The maximum induced voltage is 18.11. In conclusion, this exercise shows how magnetic flux changes with rotation and how this variation generates an induced voltage according to Faraday's law. Thank you.